The large-scale structure of the universe. Have you ever imagined that the universe, so vast and endless when you gaze at the night sky, is more than just a sea of stars? It's a place where enormous structures connect, weaving together into a giant cosmic web. Within this web lie superclusters of galaxies, massive collections of hundreds or even thousands of galaxies bound together by gravity. These are not merely clusters of matter. They are the centers of grand secrets about how the universe was formed and continues to evolve. Let's explore the story of these superclusters and their profound role in the larger picture of the cosmos. Superclusters of galaxies are the largest known structures in the universe, where thousands of galaxies are held together by gravity. Imagine standing on a hill, looking down at a glowing city full of lights. Each galaxy is like one of those lights, but instead of scattered buildings, they form tightly knit clusters, connecting into vast superclusters. Scientists define superclusters as massive structures made up of many galaxy clusters bound together in enormous spans of space, often stretching hundreds of millions of light years. Their role is not just to exist as parts of the cosmic web, but also to serve as the nodes holding other components of the universe together. According to research, a typical supercluster can contain anywhere from 10 to 100 galaxy clusters, with a total mass reaching millions of trillions of times that of the Sun. One example is the Virgo supercluster, which includes our very own Milky Way within its influence. Data from the Sloan Digital Skies Survey has shown that superclusters are the building blocks of the universe, shaping how matter is distributed across space. However, not all scientists agree on whether superclusters are permanent structures. Some theories suggest that as the universe expands, these superclusters will eventually lose their connections, with their components drifting apart. If so, are they truly the central figures in the universe's grand design? Or are they merely temporary formations in its long evolutionary journey? One of the most astonishing superclusters is Laniakea, the home of the Milky Way. The name Laniakea, which means immeasurable heaven in Hawaiian, perfectly reflects its immense size. Laniakea contains about 100,000 galaxies, stretches over 500 million light-years, and holds a total mass of more than 10 million trillion suns. Not only does it house the Milky Way, but it also connects with other galaxy clusters such as the Virgo and Hydra clusters. A groundbreaking 2014 study by astronomer Brent Tully and his team used telescope data to map the detailed structure of Laniakea. They discovered that Laniakea is not an isolated collection, but part of an even larger structure stretching across neighboring superclusters. This finding has deepened our understanding of how galaxy clusters are interconnected across the universe. Yet, Laniakea also raises many unanswered questions. Scientists are debating its true boundaries, as the clusters within it are influenced by nearby superclusters like Shapley. This leads to the question, are there clear borders between superclusters, or are they simply overlapping parts of a more complex structure we haven't yet fully uncovered? Superclusters don't exist in isolation. They are part of the cosmic web, a network of dark matter and galaxies interconnected like a massive net. Picture a spider web illuminated with light, where the threads are dark matter, and the galaxies sit at the intersections. Superclusters are the knots in this web, keeping the universe connected and shaping how matter is distributed. Data from the Planck telescope has provided strong evidence for the existence of this cosmic web, showing that superclusters are linked by bridges of dark matter stretching millions of light-years. One of the most remarkable images is a full map of the cosmic web, revealing dark matter filaments weaving between superclusters like lifelines of the universe. These connections not only provide stability, but also help us understand the universe's expansion and evolution. However, some researchers question whether the cosmic web is as stable as it seems. With the universe's expansion accelerating due to dark energy, will these connections endure or eventually break apart? If the web disintegrates, the universe could become a fragmented expanse where galaxies drift in isolation, no longer interacting with one another. The story of superclusters is a testament to the wonders of the universe. From their role as central hubs connecting galaxies, to the grandeur of Laniakea, our home, and finally to their relationship with the cosmic web, they create an inspiring and vast picture. But what will happen as the universe continues to expand? Will these superclusters and their intricate web of connections last forever? Or are they temporary structures in the endless flow of time? The answers remain beyond our grasp, waiting for the next steps in our journey to uncover the mysteries of the cosmos. Have you ever wondered what the universe would look like if we could see it from above? Would it just be an endless void filled with stars? Or would it reveal a more complex picture, with threads of matter weaving everything together? In reality, our universe isn't just a chaotic mess of galaxies. It's structured as a massive network, a cosmic web. This is not easy to imagine, but the cosmic web holds the key to understanding how matter is distributed and organized in the infinite expanse of space. The cosmic web is one of the most wondrous and intricate structures humanity has ever discovered. Picture a gigantic spiderweb stretching across the universe, where dark matter filaments form the threads and galaxies sit at their intersections. This is how the cosmic web works. Filaments spanning hundreds of millions of light-years connect galaxy clusters, creating a universal network. These dark matter filaments, though invisible to the naked eye, are foundational, acting as the skeleton that holds everything together. Data from the Planck telescope and the Sloan Digital Sky Survey, SDSS, have allowed scientists to create detailed maps of the cosmic web. These images reveal that dark matter filaments not only connect galaxies, but also shape how they are distributed in space. A 2021 study showed that these filaments can stretch up to 10 million light-years and make up most of the universe's mass. However, the cosmic web remains a great mystery. Some scientists question whether dark matter truly exists or if it's merely an explanation for phenomena we don't yet understand. Without dark matter, could the cosmic web maintain its structure? Or is it simply a random arrangement? These questions challenge us to deepen our understanding of the universe's essence. The cosmic web isn't just a marvelous phenomenon, but also a legacy from the universe's earliest moments. After the Big Bang around 13.8 billion years ago, matter in the universe wasn't evenly distributed. Tiny irregularities in the sea of primordial energy gradually formed dark matter filaments, eventually creating the cosmic web. In these regions, the first galaxies were born. Scientists use computer simulations to recreate the formation of the cosmic web. For example, the illustrious TNG model has recreated how matter condensed into filaments, forming the web-like structure we see today. These simulations also reveal that the cosmic web continues to evolve as gravity pulls galaxy clusters closer while the universe expands outward. But is the cosmic web a universal phenomenon, or merely the result of a series of random events in the universe's history? Some researchers argue that current simulations rely on unverified assumptions. If the irregularities after the Big Bang didn't occur as we envision, the cosmic web might look entirely different, or might not even exist. Understanding the cosmic web also means understanding how matter is distributed throughout space. Dark matter filaments not only connect galaxies, but also act as channels for the movement of gas and energy. This explains why some areas of the universe are rich in galaxies and stars, while others remain empty, known as cosmic voids. A 2020 study from the Very Large Telescope in Chile discovered massive streams of hydrogen gas flowing along dark matter filaments, fueling galaxies to form new stars. This finding demonstrates that the cosmic web isn't just a static structure, but a dynamic system, nurturing and developing its components. Yet, can we fully trust these findings? Some scientists argue that data collected from telescopes might be limited by current technological constraints. Are the voids we observe truly empty, or are they regions we simply cannot yet see through? This raises questions about the limits of human understanding when faced with the universe's complexities. The story of the cosmic web is a journey into the interconnectedness and organization of the vast cosmos. From invisible dark matter filaments to their formation after the Big Bang and their role in shaping the distribution of matter, every aspect reveals new wonders. But questions remain. Will the cosmic web continue to exist and evolve, or will it dissolve under the relentless expansion of the universe? Are these structures eternal, or are they temporary features in the endless flow of time? These mysteries, though still unanswered, inspire us to keep venturing into the infinite realm of space. Did you ever think about how, in a universe filled with billions of galaxies, there could be regions that are almost completely empty? Spaces without twinkling lights, without clusters of stars or galaxies, just vast stretches of darkness? These aren't flaws or missing pieces in the universe, but an essential part of its grand design. These cosmic voids are not merely the absence of something. They hold a key role in uncovering the greatest mysteries of the cosmos. Let's explore these strange and fascinating empty spaces. Cosmic voids are vast regions of space where very few, if any, galaxies exist. Imagine looking at a map of the universe. Instead of seeing dense clusters of galaxies glowing brightly, you find dark, silent spaces, gaps in the cosmic fabric. These are the voids. They can span from 10 million to over 150 million light-years across, taking up about 80% of the universe's volume, making them some of the largest features we've ever discovered. Scientists have identified these voids through large astronomical surveys, such as the Sloan Digital Sky Survey. One notable example is the B20 void, one of the largest known, stretching 330 million light-years across. Yet, even within this emptiness, a handful of lonely galaxies can be found, like specks of dust suspended in an endless black sea. This makes voids intriguing targets for studying how matter and energy are distributed across the cosmos. However, not everyone agrees on the nature of these voids. Some scientists argue that they aren't truly empty, but filled with dark matter, a mysterious, invisible substance with powerful effects. Are these voids truly nothingness, or do they conceal secrets that we have yet to uncover? The existence of these voids is no accident. They were shaped by the evolution of the universe itself. After the Big Bang, matter wasn't evenly spread out, but began to cluster into filaments of dark matter and galaxies, leaving gaps between them that became voids. Interestingly, these voids stand in stark contrast to superclusters, the densest concentrations of matter in the universe. A study using the illustrious TNG model revealed that about 80% of the universe's matter is concentrated in superclusters and cosmic filaments, while the remaining 20% resides in voids. This explains why voids lack bright matter. Furthermore, as the universe expands, these voids grow larger, pushing galaxies farther apart and becoming even emptier. But if voids keep expanding, will this lead to a completely fragmented universe where galaxies lose all connection? Some theories suggest that, in the distant future, the universe's expansion could turn these voids into entirely isolated spaces, altering how we perceive the universe's interconnectedness. Cosmic voids are not merely empty regions, they are crucial for studying dark matter and dark energy. Because they lack the bright matter of galaxies, voids offer an ideal environment to explore the effects of these invisible forces. They serve as natural laboratories where the influence of dark matter and dark energy can be observed more clearly. A 2022 study using data from the DESI telescope measured the expansion of voids, providing direct evidence of dark energy's role in pushing matter apart. Scientists believe that by studying how light from galaxies behind these voids bends as it passes through, they can learn more about the nature of dark matter. Yet many questions remain unanswered. Some argue that because voids are so vast and contain so little bright matter, measurements and observations may not be entirely accurate. Are the phenomena we observe within voids truly representative, or are they just small glimpses of a much larger picture we've yet to fully grasp? Cosmic voids are not simply empty spaces, but a testament to the intricate balance of the universe's structure. From understanding their characteristics and formation to their role in uncovering the mysteries of dark matter and dark energy, each aspect opens a new door to exploration. But what happens if voids continue to grow indefinitely? Will they become completely isolated regions in the future? These unanswered questions fuel our curiosity and drive us further in our journey to understand the vast and boundless universe. Did it ever cross your mind how the universe, from a single massive explosion, evolved into the vast space filled with galaxies, superclusters, and voids that we see today? Many people think of the Big Bang as a single moment, but the truth is far more intricate. The Big Bang was merely the beginning, and from that point, the universe has continued to expand, develop, and form the grand structures we know. But what truly drives this process? And where will the future of the universe lead as it keeps expanding endlessly? The expansion of the universe is one of the greatest discoveries in the history of astronomy, and it plays a critical role in shaping the universe's large-scale structures. Imagine the universe as a balloon being inflated. From a tiny point, galaxies are pulled away from each other in all directions. This constant expansion of space has allowed vast structures like superclusters, the cosmic web, and voids to emerge from tiny fluctuations in matter density after the Big Bang. In 1929, Edwin Hubble discovered that galaxies are moving away from each other at speeds proportional to their distances, evidence that the universe is expanding. This phenomenon is known as Hubble's law. Data from the Planck telescope shows that the universe has been expanding for over 13.8 billion years, and this expansion is accelerating, driven by dark energy. However, not everyone agrees that the universe's expansion is the sole factor shaping its large structures. Some theories suggest that gravitational forces between galaxy clusters, or interactions between dark matter and dark energy, also play vital roles. Have we truly understood all the forces at work? Or are there still hidden mysteries waiting to be uncovered? Without dark matter and dark energy, large structures like superclusters and the cosmic web could never have formed. Dark matter, though invisible, acts as the skeleton of the universe, holding galaxies together. Dark energy, on the other hand, is like an unseen force pushing the universe to expand faster. These two elements, while opposing, work together to shape the universe's evolution. Studies from the WMAP and Planck space telescopes reveal that dark matter makes up about 27% and dark energy about 68% of the universe's total energy density. For example, simulations like Illustris TNG show that dark matter filaments concentrate hydrogen and helium gases, providing the raw materials for galaxies and stars to form. Without them, the universe would be a disconnected expanse with no order. But what exactly are dark matter and dark energy? To this day, they remain some of the biggest cosmic mysteries. Some scientists believe dark matter is made of yet undiscovered fundamental particles, while others think dark energy is a property inherent to space itself. Or could it be that both concepts are misunderstandings of physical laws we don't yet fully grasp? These questions continue to drive our pursuit of knowledge. As the universe keeps expanding, what will happen to these large structures? Some theories suggest that they will grow further apart, leading to a future where galaxies and even galaxy clusters lose all connections. This scenario, known as the heat death of the universe, describes a cold, empty universe where matter becomes isolated. Data from the DESI telescope offers deeper insights into the universe's expansion rate, showing that dark energy is becoming increasingly dominant. Some predictions even propose that if the expansion continues to accelerate, galaxies and stars might one day be torn apart in a scenario known as the Big Rip. Yet, there are other perspectives. Some scientists hold hope that the universe could reach a state of equilibrium, where dark energy no longer dominates and large structures remain stable. Will the universe expand forever, or will it eventually stop and collapse? This remains one of the biggest unanswered questions in cosmology. From the universe's continuous expansion to the role of dark matter and dark energy and the possibilities for its future, every aspect is a piece of the universe's grand tapestry. But have we truly grasped its journey? As the universe continues to expand, what secrets will it reveal? And will we ever find answers to questions that have spanned centuries? These mysteries not only propel science forward, but also ignite humanity's boundless curiosity in the quest to explore.